Welcome, focus learners. Okay, so if you're gearing up for a physics exam on moments and levers, you are in the exact right place. Seriously, think of this explainer as your interactive masterclass study guide. We're going to walk through everything you need to know from the source material, step by step, to absolutely crush that upcoming test. No distractions, just clear visual learning. Let's get into it. Here's our game plan for today. First, the turning effect. Second, mastering moment calculations. Third, the 3 lever classes. Fourth, identifying everyday levers. And finally, a final exam practice quiz to lock it all in. Section 1. The turning effect. Understanding the basics. All right, let's dive right in. Right out of the gate, we've got to anchor our core concept. Now, a moment in physics isn't, a brief period of time. It's officially defined as the turning effect of a force around a fixed pivot point. You're definitely going to want to lock that into your memory because it's almost guaranteed to be a straightforward definition question on your test. Basically, applying a simple, straight force to an object causes it to rotate around its foundational pivot point. Imagine a seesaw on a playground, right? The pivot is that little triangle at the bottom, and when you push down on the beam, the whole thing doesn't just fall straight to the ground, it turns in an arc. That turning action, that is the moment. Now, here is a massive key for your exam prep. The moment depends not just on the force applied, but on the perpendicular distance from the line of action of the force to the pivot. Listen to me on this. Memorizing that specific phrase, perpendicular distance, is absolutely vital for scoring full points. If you just write distance, you're probably going to lose easy marks. So, perpendicular distance. And keep in mind, forces can make things turn in 2 different rotational directions. We contrast these pretty simply. Clockwise moments versus anti-clockwise moments. Honestly, identifying the correct turning direction is half the battle when you're looking at complex engineering diagrams. A great trick is to always pause, look at the arrow, and ask yourself, okay, which way would a clock's hands move if I pushed it exactly like this? Section 2. Mastering moment calculations, the golden formula. So here's the golden formula. Moment equals force multiplied by perpendicular distance. But, and this is a big but, the crucial detail you need to heavily stress in your notes is the unit. It's Nm, or Newton meters. This is literally one of the most common exam pitfalls. It's so easy to calculate the right number, but then mistakenly write down newtons or joules. Don't do it. The unit for a moment must always be Newton meters. Let's actually walk step by step through a classic word problem from the text. Imagine a door hinged at one end. Step 1, we're told the minimum moment required to open the store is 45 Newton meters. Step 2, the distance from the hinge to where we push is 1.8 meters. Step 3, to find the minimum force, we just rearrange that golden formula. Force equals the moment divided by the distance. So 45 divided by 1.8 gives us exactly 25 newtons of force needed. Boom, easy. And this math brings up a really fantastic conceptual question. Why is it easier to push a door open at a position super far away from its hinges? Think about it for a second. When we increase the perpendicular distance, we need way less physical force to achieve that exact same turning effect of 45 Newton meters. A greater distance just effortlessly increases the rotational force effect. Like try pushing a heavy door right next to the hinge. The distance is tiny, so the force you need becomes incredibly huge. No way you're opening that easily. Moving on to Section 3, the 3 lever classes, the FLE 1-2-3 framework. Okay, if you've ever struggled to remember which lever is which, the source material gives us this absolute game changer of a mnemonic, FLE 1-2-3. Think of it like this. 1-2-3 matches up perfectly with FLE. First class means the fulcrum is in the middle. Second class means the load is in the middle, and third class means the effort is in the middle. I'm telling you, this is literally a cheat code for your test. Let's picture a first-class lever structure. Here, the fulcrum, the pivot point, sits perfectly right between the effort pushing on one side and the load reacting on the other. A great way to visualize this is to just think of a pair of scissors, a claw hammer, or a pair of pliers. Fulcrum right there in the center. Now for a second-class lever, notice how the load is trapped right in the center. That's the L in our FLE 1-2-3 rule for Class 2. The pivot is up at the very front, the effort is lifting at the far back, and the heavy load sits right smack in the middle. Think of a wheelbarrow or a nutcracker. This setup traps the weight and gives us a massive mechanical advantage to lift really heavy things. And then we have the third-class lever. Here, the effort, the E in our mnemonic, is applied directly in the middle. So the pivot is pinned at one end and the load is out hanging at the far end. So what's the real difference here? Let's compare the mechanical advantages. With first and second class levers, the effort usually moves through a larger distance to give a larger force effect on the object. You're basically trading physical distance for raw power. But third class levers, they're completely different. We actually apply more effort over a smaller, tighter distance, which produces a large, sweeping, super fast movement of the load at the end. You're trading force to swing a load faster and wider.
Section 4. Identifying everyday levers. A matching game.
Let's simulate some active recall right now to wake up our brains. We're going to look at a few everyday household objects, and I want you to try and mentally use that FLE 123 rule to figure out the lever class. You ready? Let's do it. First up, the trusty broom. Think about how you actually sweep. One hand holds the very top of the handle perfectly still, right? That acts as the pivot, or the fulcrum. Your other hand is pushing right in the middle to do the actual sweeping. So that's your effort. And the dirt at the bottom is the load. Because your hand applies the effort right in the middle, our FLE 123 rule instantly tells us, yep, this is a third-class lever. Okay, what about a pair of kitchen tongs? Well, they're permanently joined at the back, so that hinge is obviously the fulcrum. We squeeze them with our hand right in the middle. There's the effort. And they grab a piece of food at the open end. That's our load. Once again, the effort is squarely in the middle. Tongs operate on the exact same mechanical principle as the broom or even a fishing rod. They are all fantastic examples of third-class levers. Now for a really cool biological example. The human arm. Your elbow joint is the stable fulcrum. The load is, say, a water bottle sitting in your hand. But where is the biological force actually pulling from? Well, your bicep muscle attaches right to the middle of the forearm bone, pulling it upward. The effort is completely central. That means our very own muscles are biological third-class levers, trading internal force for the amazing ability to move our hands quickly and through a really wide range of motion. How cool is that? Section 5. Final exam practice quiz and checklist. All right, here is your final summary checklist to help you avoid those common exam traps. When calculating moments, immediately double-check that you are using the perpendicular distance. Always, always confirm your final answer is boxed with the correct unit, Newton meters. When categorizing real-world objects into levers, instantly rely on that FLE 123 mnemonic. And finally, always take a split second to note if the turning effect is clockwise or anti-clockwise. If you check these off, you are going to be unstoppable. So here is a provocative thought to leave you with today. We've mastered the math and the physical tools, but our own bodies are incredible mechanical engines built entirely on these exact same physics principles. If your arm is a third-class lever, what about your foot when you stand up on your tiptoes? Or your jaw when you bite down into an apple? Keep exploring those hidden biological machines. You are now fully empowered, deeply curious, and totally prepared to ace this physics exam. Keep learning, keep observing, and good luck.